Good morning, everyone. Thanks for coming to talk about accelerating your advanced analytics in Tableau. My name is Bora. I'm the product manager for the advanced analytics team, I guess, in Tableau. Just to give you some idea of what I intend to achieve in this session, because this is marked as intermediate, yet the title talks about advanced something. So we have some internal aliases where a lot of questions from the customers pour in. It comes from customer support, it comes from product consulting, and there are some recurring themes. And sometimes the answer to the question is, have you considered doing this? And they will go like, now that I know what to look for, I can just Google it, find out the exact solution, because I didn't even know what the answer was before. So I went through all of these cases that commonly happen, and I thought maybe I could put together a session that says, here's what you can do in Tableau, here's the value. Even though you don't learn exactly how to apply it in your database or in your ETL environment in this session, because it's intermediate, and if you wanted to do that, you probably have to spend the next 6 months in this room, you could at least identify the problem, think of a solution, like UDF might be a solution for this, and go look for that word in Google. And this statement, especially if my slides move, resonate really well in this day and age. Even though it's more than 200 years old. Now with that, we have internet and Google. You just need to know what magic words to type into a box to get to that information. So I'll try to help you identify those magical words and associate with your tasks at work. That's what this session is all about. When I think of analytics, I think of it in 3 large categories. The first one is in-database analytics. This is something you may want to do if you have, let's say, a database that you can push analytics to, that you can internally run certain functionality, and you have some large data. You could do maybe the same thing inside Tableau, but you don't want to move over billions of rows in a Tableau to do the analysis, because maybe you can run the analysis, all you care about is 10 rows after that analysis. You apply the filter, the chances of customers churning, give me the top whatever customers. Well, you just need those top customers. You don't need the entire data set in Tableau. So it'll be much faster, and maybe your database could have capabilities Tableau doesn't have. In that case, it makes a lot more sense to run it inside the database. The second one is pre-processing, or batch processing. And this is more applicable if you're doing large-scale data transforms. Sometimes they change the shape of the data significantly. Sometimes the data is really large, so it will take models to run overnight, maybe. So it doesn't make sense to do it on the fly. Try to do it inside Tableau. And maybe the nature of the data even doesn't require that kind of real-time interaction. For example, you could have, let's say, tweets coming in maybe at the end of every day, you look back and get a whole day's worth of tweets, run sentiment analysis on them, or whatever, and then you can put them in a database. So the next morning somebody comes in, everything is pre-processed. Since it's pre-processed, it's really fast, and you really don't need to process this data on the fly. And oftentimes, for this kind of analysis, what you're doing is a row-level transform, so the answer is always the same. Taking the example of Twitter, for example, a given sentence will always give you the same sentiment, regardless if you ask the question today, a week later. So you really don't have to recompute the same answer over and over again in a lot of cases. And finally, I call this local calculations. This is typically stuff you will do in Tableau, adding trend lines, ref lines, doing table calcs, etc. Or R or Python calculations. And the reason for this could be multiple things. One, maybe you want interactive analysis. You want some input from the user. You want something to change the results based on that input. Your data is not super large, and in some cases, you can't technically push it to the database. And this could be because 1, database doesn't have the capabilities that you want. 2, there are multiple databases. Because in Tableau, if you do a local calculation, you can bring in data from a blended source or do a cross-database join. But even if you had the option to push the analytics to the database, what if you have an Oracle database, Excel, and a SQL Server? Which one do you push? The data comes from multiple places. So there might be reasons local calculations could be the only answer in certain cases. So before we start, I have a little magic trick kind of a thing. So I need some audience participation. If our server is still alive, let me show you this dashboard running on one of our test Tableau servers. These are the tweets about the session using the hashtag for the session. You could see there aren't that many, and there's a word cloud. So I will ask you to kindly help me, and I'll leave this open, and I'll go back to my slides. So if you could help me with this demo and tweet something that uses the hashtag for the session, we'll go back to that demo in about 20 minutes, and we'll look at the dashboard and see what happens. And hopefully, it will look different, including all the tokens from your tweets, the counts, without me having to refresh the viz or anything. Somehow, your data magically makes it from Twitter into my Tableau dashboard. OK, let's start with in-database analytics. I'll break this down into multiple topics. First, I'll start with custom SQL and raw SQL. This is actually an example that came less than 2 weeks ago through our customer support channels. And somebody was trying to do a forecast on top of a window average. They had this problem because data had a lot of noise. Forecast by itself didn't give a good forecast. They wanted to smooth it out by applying some sort of a moving average. But if you tried using table calcs to do a window average in Tableau, then you try to add forecasts, you will see the forecast is disabled because we don't allow you to mix them yet. This is an example to demonstrate the case, but this is more widely applicable solution to many problems. So your databases have functions that are very similar to a table calc in Tableau. They run inside the database, so it comes in as a regular table in the Tableau. Tableau doesn't know anything about what the database did, so you can treat it like any table. And there are several functions. They're called SQL analytic or window functions, if you wanted to Google them. And many databases offer them, from Oracle to Vertica to SQL Server to Postgres. So you can go look it up to learn more about them. And you can do things like running totals and lookups and ranks and window averages, et cetera. Let's see how you get to custom SQL in product first. If you connect to a database, that is a relational database that we talk SQL, so that excludes things like cubes or extracts themselves, right? Then you will see an option that says New Custom SQL at the bottom of the list of tables that you have on the left-hand side. And you simply drag that into your view. When you drop, it will pop up this dialog, which is typically empty. In this case, I put some SQL. You shouldn't worry about the syntax. I'll just highlight the things it is doing. It is just to give you an idea of the scenario. So in this case, I'm doing a 4-month moving average for each customer segment. It says preceding 3 and current row. And I'll consume these results because custom SQL returns a table that I can read in Tableau. Then I parameterized it because there's an option in this dialog that says insert parameter. So I can put widgets in Tableau, and I can change how many days or how many months moving average I'm doing. And you can see the parameters in gray, parameter.something in the script. So this is what my final result looks like. I essentially took it, and I was able to add the forecast on top because there's no table calc to do the moving average. And you can see the controls following and preceding. So I can, in this case, it is 6-month moving average, 2, 3, plus 1, that's the current month. But I could change on the fly. And all the calculation about moving average is actually being pushed to the database. You may want to do something like this, for example, if you have a rank calculation that you want to do a filter on in the database, but table calcs offer rank, but you can't use it as a filter in that sense because we don't push table calcs down to the database. So custom SQL is not the only way. There's also raw SQL. But before we go there, let's talk about other kinds of functions that you can use in your database. Most of the relational databases, even NoSQL databases, have this concept of user-defined functions. And some of these functions are called user-defined, but even the database vendor themselves use this as an extensibility module for themselves. I'll show you an example from SQL Server. For example, in SQL Server, the spatial functionality is built as user-defined functions, even though it comes from the company itself. The nice thing about user-defined functions is you can define them because they are user-defined functions. And some databases even offer you the options to write user-defined functions in C++, Java, C, R, Python, depending on your database. which means you can put a lot of predictive power in those functions. I'll show you briefly how to call those functions, but you can call them in SQL inline. You could do a select using a function, and it will do the transform for you on the fly. And there are 4 types of these functions. The scalar functions that are row-level transforms. Let's say you have a function that takes degrees in Celsius and converts them to Fahrenheit. That will be a scalar function. Or it takes a string and strips out characters, takes the first 3 characters. That's a row-level operation. That's a scalar function. You can have an aggregate. That is like a sum or an average. Let's say you don't want to do the arithmetic mean. You want to do a geometric mean. You want a function for that. You could write that as a UDF. And analytic functions that we just talked about. And finally, the table-valued functions, which return tables. A good example for this is if you're doing something like a split calculation in many databases. It will take a string, it will tokenize. Let's say you're using spaces, you get different words for a sentence because there are multiple words. And sometimes they will create this mini table where each row is one of the words. Then you can index by using square brackets. Give me the first token, a second token. So it is a mini table that returns that you can index. So you can write all of these in various languages depending on the database you have. And it could be Spark, it could be Cloudera Hadoop, it could be Vertica. Look at your database documentation. Pretty much any database supports these kind of functions. So let's look at an example of how you can leverage a function to do something cool in a database. In this case, I'm using data from US Census Bureau, and it has the Tiger census tracts. And currently, as you know, Tableau can't read spatial data in the forms of polygons from a database. We can connect to files right now, the shape files from our ArcGIS, but not to databases. So let's say I want to display this data on the map. When you connect to this table, you won't even see all of the columns because the geography is saved in a column called geo. It is a binary column. It is a data type we don't recognize, so you won't even see it in Tableau. But if you use the functions, you could get things like the centroids, the area, the circumference, etc. All these information about the polygons that you can use because latitude and longitude are numbers that we can display in Tableau. So raw SQL functions are in the calculation editor, as you can see here in the flyout. I'll go over the syntax with more examples, but this is essentially where you can find it. And I'll zoom in a little bit so you can read it better. So in this case, I can get the centroid of the polygon and extract latitude and longitude like this. Geo is the underlying column that contains the polygon. I can get the area. In this case, it's square meters. I'm converting it to square kilometers by dividing. And I can even apply filters. So in this one, what makes it more interesting is I have 2 arguments that I'm feeding into the function. And I'll highlight them for easy reading. The first argument, the location, is passed as $1. And the second argument is the radius of meters is $2. It's an ordered list of arguments. So if you have a third, that will be $3 and 4. And there's no limit. We support as many as you like. So what this is doing is essentially it's picking a point. That's the location, which corresponds to this table. It is a string of points. Let's say this is your store locations. And you're trying to find customers within a certain radius, miles or kilometers radius of that store. Then it takes the radius in meters, puts a buffer around that point. So it creates this circle around it. And then it uses this intersect function that SQL offers to find the points that intersect with that circle, which is your radius search around the store. So essentially what you're doing is a filter that says whether these people are within X kilometers of this store. And if you put this in a view, you can get an experience like this. You pick a location, and location is the orange dot, and I can change the meters radius on the fly. Database is actually doing the spatial join, spatial intersection operation, so I am able to do a spatial search. But this is one example. Many databases have data mining functions. Oracle has several. Again, you could write your own if you wanted to. If you don't want to write your own, maybe your database admin, if told, like, here's something I learned, I think we can do it in a database, and it will give me a lot of power, maybe they'll do it for you. So we talked about scalar functions. The function I just showed you that gets the latitude and longitude for a given polygon, since it's a row-level operation, it was scalar. How about using an aggregate function? So I'll use this example to solve a common problem a lot of people face. Let's say you have this bar chart and you want to understand the product types at a given point. You use an adder and you get this asterisk. But you actually want this comma delimited list of stuff that was sold, not an asterisk. Well, you could use an aggregate function. I'll just zoom in quickly. This is MySQL. I try to use different databases for my different examples to kind of be impartial to our partners. But it has a group concat function. A lot of databases have something that does this. They might have slightly different names. And it just takes things that you're grouping by, which is your dimensionality in this case, the dimensions that you have in the viz, and instead it just concatenates them using commas. So you can see the result. I'll just highlight. You could see if you look in the tooltip now, my product type, instead of an asterisk, it says coffee, herbal tea, and espresso, because it concatenated instead of giving me an asterisk. Again, this is a custom aggregation. It's not a usual aggregation, because when you think of aggregation, you think of things like sums and averages and medians. So you could do a lot more interesting things if you wrote your own using a UDF. Another way of doing in-database analytics is stored procedures. So far, I didn't talk about specific database names, because if you have a UDF, you call it using SQL, which means we can do it on any database. But stored procedures, we don't offer the option other than these 4 databases, so I'm explicitly listing them. So Oracle, SQL Server, Sybase, and Teradata. Well, how do you get to it? So if your database supports it, and if you have stored procedures, when you connect to the data source, under the list of tables, you will see a section dedicated to stored procedures. And you can drag it in just like any other table. And the moment you drop, will pop up a dialog that allows you to enter the parameters required, if any, for the stored procedure. Because stored procedures are kind of like a form applications, you could ask people to provide some information before you give them the answer. And the nice thing about it is it will run once, and we'll create an extract out of the results. So we won't be running the same stored procedure over and over again. It's a pre-processing step, so your subsequent actions will be much faster. So we talked about things that you may ask your database admin to do, or if you have the admin rights, you could do yourself. But in some cases, you don't. So this is, again, something the admin can block you from doing, but at least you're not deploying something, so there's a possibility you'll be able to do it. Initial SQL is something that we run at the very beginning of the connection. When you connect to a database, we run it once. You could use it to set variables. You could change the locale. You could do a lot of things. Or you can even run some sort of pre-processing script that processes the data and puts the results in a temporary table that you read later. So it's purely meant for pre-processing. And we support it on many databases that you can see here. Some allow parameters, so you can make it more interactive by putting the controls in the dashboard. Some currently don't support parameters. So how do you get to initial SQL? In the connection screen for each data source, you will see if it's offered on the left-hand side as a link. Also, after you connect, if you want to modify it, it's under the data options in the menu. So let's go through an example to solidify it a little bit. In this case, let's say I have the survey data set, and it's a long table. So the questions I ask, instead of putting them in separate columns, I decided to put them in a long table where each question is a row. But let's say your analysis requires them to be columns. So you have to transform the data to a white table. And that's a pivot transform. And your database may actually, some of them support a pivot transform. And in this case, I'm using SQL Server. I have some extra rows here just to make a point. For example, I'm getting the current timestamp and adding that as part of my select statement. The reasoning behind this is you can see how flexible it is to write initial SQL. If you write custom SQL in Tableau, we just ask you to write a select statement. It has to return a table. It has to be a single statement that we can run. But if you do something like initial SQL, you can put as many steps as you want. You could declare variables, you could set values, you can do loops, you could do whatever you want. And we'll just run it. We don't care if it returns anything at all or returns something. We really don't do anything with it. So in this case, I set my variable, get the current timestamp, then I actually do my transform. And here you can see my pivot highlighted. And in the end, I get the results and put it into this temporary table. In this case, the pound sign indicates a temporary table. And a temporary table is essentially something that lives within the context of the session. So some other user connecting to the same dashboard won't see your data. You can't see their data. It is limited to your own session. And once you terminate the session by closing Tableau, database will garbage collect all the unused tables. So you're not accumulating unnecessary tables on the database by creating temp tables. So now that I define my query, it puts the results into this demo temp table. I can do a select star from demo temp, and it will give me a table like this, which is what I'm trying to get to, my timestamp for the demo purposes plus the pivot transform. So you could do a lot more pre-processing like this. Certain databases have things like text analytics built into them. Like if you have Aster database, they can do log analysis. You could look for patterns, people who landed on this page, and after 5 clicks who went to this page, it will extract and give you a table from unstructured log data. So look at your database documentation. You could do a lot fancier things than just a simple pivot. Okay, so we talked about all the things that you can do inside the database. Let's talk about stuff that you will do outside and somehow persist in some format. So you need pre-processing in certain cases. One could be you're working with certain data that Tableau doesn't connect to. If you're a scientist, you may be familiar with some of these formats like NetCDF, HDF5. They're binary formats, they're hierarchical. A lot of scientists use because they can handle large amounts of data. But it's really uncommon in the business intelligence community. So it's unlikely that Tableau will have a connector for it soon. You could be working with map data. Typically they're in a grid raster format. And again, it's not the typical format Tableau expects to be able to connect to. Your data could be completely unstructured, like the text data. It could be call center logs. It could be product reviews. And you may want to pre-process them into a table that can give you the common words, the sentiment. It could extract entities. People are talking about this location versus this business entity. Once you get into a table form, it's a lot easier to read. So this is another good candidate for pre-processing. And again, sometimes the data is in the right shape, but you need some basic transforms that are costly to compute on the fly. You want to do it up front, put it in a database, maybe do it overnight, over the weekend, then you can read from Tableau. So it's purely for performance reasons. We do this through our many partners. You could roll out your own. I'll show you some examples soon. But in this case, you could do a pool model using web data connectors for Alteryx and LavaStorm. This is something we announced not long ago. Essentially, let me walk you through an example with Alteryx. In Alteryx, you will see a Tableau tab, which is cut off in the screen because it's a really wide screen. But if you go there, there's an option called Web Data Connector for Tableau. You need to drag it in. Once you do, it essentially creates a Web Data Connector for the flow that you just generated, which you can publish. Once you publish, you will see that option in your gallery, and you can search for it. And once you found it, it will also give you options like a stored procedure, essentially. You make your selections, and you hit Connect. It will run the workflow, your Alteryx workflow, and give you through Web Data Connector an extract that you can connect to. So again, this is a pre-processing step where you're pulling data by running the flow on the fly. Then there's the opposite. You can actually push the data from the environment that you have. And we're a lot more flexible because in this case, we really don't have to integrate with that data source. You could be working in any environment, and you can just push it out to a CSV if they support a CSV export. For certain environments, we have better integration. For example, if you write our data file, we are able to read that, even though it's a binary format. Same thing with SPSS and SAS save files. We can read those data sources as well. You can always write into your own database. If you can connect to that database, we'll get the data that way. And we have Tableau Extract API. If you want to create an extract, that is also possible. And you can do this, again, using one of many of our partners or by yourself using Python or R. I just listed them in detail, and I'll have a slide at the end for those in the expo hall if you want to learn more about them. Okay, so let's go back and see what happened with my, let's close this and look at the previous one. Okay, so we have 10 tweets. So I'll explain. I'll explain to you, and a tweet is the biggest one. Okay, so I'll explain to you how this works, and I'll wait for another 15 seconds so you can see it refresh automatically, because this is another common question we get. People are trying to do this operational dashboarding in Tableau. I want the data to automatically refresh. How do I do it? And this actually does that. And we're processing. We have this pipeline that, as you can see, it's automatically refreshing, pushes the data from Twitter, and refreshes the view. And this doesn't require any expensive products. I did it using just free stuff. Okay, let's go back. And that's probably the most popular viz in our system right now because it refreshes every 30 seconds, so it has thousands of views. Okay, so how does this work? Come on. Okay. So in this case, I have a do-it-yourself data pipeline. And I use the Python script that uses Twitter Python API to scrape Python, and then uses it writes the results to a CSV. And Tableau has a command line utility to allow you to push that data into an extract on the server and do an append operation. So we're adding the rows every 5 minutes to that extract. And to do it every 5 minutes, I have a Windows task scheduler task that kicks off this script every 5 minutes. So it's off-the-shelf free stuff. If you want to do this on something like Linux, there's cron instead of task scheduler, so you can do it yourself. And to make it extra refreshing, I put a refresh tag in HTML that causes the dashboard to refresh every 30 seconds. So you have this view that has this kind of a streaming dashboard kind of a feel. We can look at the pieces of it. So, and please don't try to read the details. You will have access to the slides. It's more about showing you the pieces. So we have the really simplistic Python script. It just tokenizes. There's also some cleanup that I'm not showing here that gets rid of things like ands and this and it's and this. The stop words that are not extremely meaningful. Then we have this call. You can see you could also run in command line that connects to my Tableau server. I blurred out the server name and my credentials, but there's a call that says add file to extract using Tableau exe, and it will update and take my CSV that I just generated here and append it to the extract. And this is my task scheduler task in Windows that runs every 5 minutes. It's run 171 times during my demos, apparently. And this is what the HTML page looks like. And I highlighted some of the things. Here's how you do a refresh of the dashboard itself every 30 seconds. And you have to add refresh tag. And the code you're seeing here is mostly copy-pasted from the share option for the dashboard. If you go to a dashboard, there's a share link. It will give you two things. One is the link that you can share. One is what you can embed. This is the portion that's in embed. I just copy-pasted it into an HTML page and added the refresh tag. And I was able to generate this refreshing dashboard. Okay, so you can also create workbooks. We talked about creating data sources and pre-processing so far. And I'm not going to go into details on this. We have 2 partners that do this. And in some cases, sometimes you do some analysis, you train a model, and there's some sort of visualization that goes with the model to give you an idea about how well the model fits. Let's say you do a predictive model like logistic regression. You may want to see the ROC curve. You can have a decision tree where you may want to see the confusion matrix. So there are things that go with the type of analysis. And maybe in those cases, you want to create the whole dashboard that contains the data and these diagnostics visits programmatically. And if you want to do it yourself, we also have a Tableau document API that allows you to create Tableau XML documents programmatically. Let's move into more the real-time stuff, Python and R integration. I like this code because it talks about how you would discover more things as you analyze, and it will help you ask more questions, so you'll discover even more as you go. Often, the question you had in the beginning is not what you end up answering in the end. So when you use something like local calculations, This is more likely because first, you don't have to ask your admin to write anything. It's dynamic. You're in Tableau as you're exploring. You can add these things. So it will help you discover things and dynamically modify your code that you're running inside Tableau to accommodate and ask more questions. And we do in two ways. We announced Python integration on Friday last week, and R, we had it since Tableau 8.1. That's about 3.5 years ago. And through these, you can call any R or Python package. We're not limiting you to the things you can call. You can have the packages you can find on CRAN that are for free. You can also work with our partners. Some of them have proprietary packages they wrote in Python or R that you can call through this integration. So I'll give you one example using the new Python connector. Okay, so this is a video. I don't know why the screenshot did not display that showed the code. But in this case, I'm using a dbScan algorithm from scikit-learn, which is a very popular machine learning library on Python, to find criminal hotspots in Seattle area. This is data from Seattle Police Department 911 calls for the past 6 years. And on visual inspection, it's really hard to find the hotspots because there's so many points. And the data quality isn't great because probably the police officer shows up on site, they pull out their GPS. It is like off by just a little, even though it's exact same location, because it is a local GPS reading. So you can't just say, I will treat the lat long as a dimension, and I'll do a group by and give me all the incidents happen at that location, because everything is slightly off, like 10 feet off here, 50 feet off here. So you have to have something smart that searches the vicinity of things, which is what dbScan does. So I'll try to do this again. If it start over so you can see it. And nice thing about this is it's parameterized. I can change the type of the crime, and it will react in real time. I can also change how far each incident should be from one another. I can look for incidents within 200 feet or 300 feet of each other. And I can say, I want at least 2 incidents a quarter or 1 incident a quarter for this spot to qualify as a hotspot. So in this case, since my slide did not work, you can't see the code, but I embedded a whole block of Python code inside Tableau. I'll show you an R example that will help. That allows me to evaluate Python code right from inside Tableau by passing the data that I'm seeing in my view. Tableau takes care of all the filtering. That's why you can change filters and will react dynamically. It controls things like level of detail. If you drill down, your R script or Python script will react to it, as you would expect. So we offer this very dynamic exploration experience. And a common use cases, as you could see also in this example, often there's a data scientist in a company, and they come up with these models, but they want a way of sharing it, presenting it with audiences that may not be super comfortable with something like Python or machine learning. In this case, you can imagine a police officer on a tablet looking at these things and trying. They don't have to know anything about Python or scikit-learn or machine learning or anything at all. They could be taking advantage of the predictive power of the dashboard. So Tableau can serve as the front end for complicated machine learning models. So in this case, by doing this analysis, I found some interesting hotspots in Seattle. This is, like you can see, 4 points in there. And there's actually 28 crimes in those 4 visible points. An interesting thing is there's 2 crimes on the burglaries within the same block on the same day, 8 hours apart. If you look 2 days ahead, so there's 3 events within a 3-day window. This is something you can visually identify because there's so many overlapping points. You can only see 4. It doesn't look that interesting. But using the algorithm, especially by converting into a human consumable format where they can say, well, a police officer knows how large a block is. They can define 300 yards as a rough size of a block in Seattle or whatever. Right? They might know what a hotspot means as a gut reaction. If there are this many events happening, it's probably something I should look into. So they can punch in those numbers and get predictive results. So R integration, I want to give you some examples of interesting things people do with R integration. It's not just the predictions. You could do a lot more things with R. In this case, I'm doing overlays of different curves and areas. For example, it's really easy to do something like a trend line in Tableau. You just drag it, it works. But sometimes you don't want to fit a line or a polynomial. You have some model that describes the process. You could say, oh, well, it has to fit a sine curve, or it has to fit a logistic curve. And with R, you can pass the data and fit whatever you want and do an overlay. You can even go beyond a single dimension. And on the right-hand side, you're seeing the bivariate kernel density estimate for the points that you're seeing here. It's like a two-dimensional histogram rendered like a heat map. And each pixel that you're seeing here is actually computed on the fly with R based on the data. If I filtered something in that view, the background image, which is not an image, each pixel is a mark, would change on the fly. And this is how much code it takes to do the graph on the right. In R, inside Tableau, you can see I have this function called script real. And essentially, I'm embedding my R code in there. It does all the processing and gives me the kernel density estimate KDE, which I'm displaying in the view. So we talked about examples of how you can use R models inside Tableau. There are multiple ways of leveraging models you trained in R. And one of them is in database scoring. So we do this in various ways. There are some partners who allow you to do this. BigML is one of them. And you could do this with your own R or Python models. So for example, this is what BigML looks like. In this case, they trained a random forest or a gradient boosted tree. And they have an option to export to Tableau. And it just gives you this gigantic if-then-else statement that you can copy-paste into Tableau. Since it's if-then-else, even though you estimated the model, the model was done outside your database using their platform, if-then-else can run on any database. Now, you're able to push that logic into the database. And again, this is a good example where you may be looking for customers who are likely to churn. Hopefully, that's a small percentage of your customers. And then you just want to bring those into Tableau. Instead of a million customers or a million transactions, you maybe want to bring in 5. By pushing the calculation to the database, you're saving a lot of time because the database just finds the relevant things for you and just returns those rows. You can also do this with R. I provided a link at the bottom. I wrote a little script. If you, let's say, have a decision tree in R, in this case, I'm creating it using rpart function in R, you can pass the model to a function that I wrote, and it will give you this Tableau calculated field. That's an if-then-else statement, as you can see in the first example. You can take this and put it in Tableau. It will run on any database. So you cut your dependency on R. You don't have to install rserve to run the model, and it's really fast because it runs inside the database. There's no data transfer happening. You can also do this with the regression models. Here is an example of logistic regression. This is giving the probability of someone getting into grad school, given their GRE, GPA, and ranking of the school. And it is, again, a model that was trained in R, converted into a calculated field in Tableau. You can copy-paste, and will run inside the database without any need to R. And it will be much faster. This extends to other regression models. Any GLM model that you train in R, it could be multiple regression. It will also work fine. And you can find the example in that link. So I would like to leave some time for questions. So I will wrap it up by saying you could go to Expo Hall to learn more about some of the things I showed by talking to our sponsors and partners. There's no more session repeats because this is the last one. There's a related session about TabPy that's happening right after this one, where I co-present. We'll talk about the details of our Python integration if you're curious to learn more about it. There's a customer session that actually talks about our integration, how they use it at FDIC, that can help you understand some of the actual use cases from like-minded individuals. Please complete the survey so I know how well I did or how terribly I did so I can improve next year. And if you have any questions, I'm happy to take them now. I think there's a microphone that we can pass around. If you're shy, we can end this and I can take the questions here, but let's try on the microphone first. Thank you.
tweet or something like that, the Python example, so that we can see the sample script?
Can you repeat the question? Sorry, I couldn't hear.
Can you tweet the Python example or share it in some way so that we can see what that script looks like?
Yeah. So what I'm going to do is all the content will go into this machine and it will be published online for you to download. So you'll have the example code, the slides, and everything. That, because I'm not expecting anyone to remember any of this. There's so much content. So you could follow at your own pace after the conference.
Okay, great.
I'm kind of curious about the R example you showed with the heat map. You said was drawn like pixel by pixel. Maybe it's a basic question, but so where do you actually put that code, and how do you get the visualization to come out on the Tableau side?
So one way of learning about this is if you go to my blog, there's a workbook that you can download that has all of those examples. You can look at it and see how it works. But so typically when you run R code in Tableau, the easiest way of doing it is you have one row in, one row out. So you have an individual, you're trying to see the chances of the lone default, and it's a one-to-one mapping. It gets a little more complicated when you do the things like I just showed, because you have, let's say, 20 rows in Tableau, and your kernel density estimate requires 20,000 rows. So we have a densification trick that a lot of people apply in Tableau. So if you use something like bins in Tableau, you will see there's an option that says show missing values. And it will generate a lot of blank spots. So what I did was I took each axis and I created really tiny bins. And then I said show missing values. So it just created this dense matrix of data points on the fly. That doesn't exist in the data source, but inside Tableau. And once you do that, R can actually fill those gaps that Tableau created on the fly. What it's doing is essentially taking those 20 data points, of course sending 20,000 because we densified it, right? It has lots of nulls. R gets rid of nulls, fits the model, the kernel density based on the 20 actual data points, and then returns 20,000 for each pixel. That does it explain. I think the best way of understanding it is downloading the workbook and looking at the contents. But I built it in 9.0, I think, so you should be able to just download and open it with no problems.
I love that Tableau has these connections to different databases, and then you can also program right in Tableau. But the one that I use all the time is Stata, and I don't know if you have any idea why Tableau hasn't found a way to connect either directly to Stata or direct integration, or if they have plans for doing so.
For Stata, if you export to a CSV, we could still read the output.
That's what I do right now,
yeah.
right? But it's very slow.
So for dynamic code execution, one thing about TabPy is if you go to a TabPy page on GitHub, we detail how it works, and it is a REST API. Tableau doesn't care what language it is. We don't know if you're running Python or R often. We just say, here's a string, we'll pass it to an endpoint, it will return something. So one thing I really wanted to do, and if you look at the GitHub repository, I'm the only developer contributing to it. What TabPy was, have a REST API that's generic that anybody can swap out any language. So it is a REST API is like a web page, right? You send a request through a browser, it gives you something. You could change the Python interpreter underneath if you're technically savvy, or if you have an enterprise IT group, and put a Perl interpreter. Now you have a Perl connector to Tableau. You can put a Java interpreter. Now we have a Java interpreter. So our infrastructure enables you to put any language. I think the TabPy is a big step in that direction. The community can come up with more stuff. We can come up with stuff faster because we're not bound to a certain interchange format like rserve, like we did with R. So I'm hoping at some point soon we will have more connectors, but unfortunately not yet.
Okay, cool. Thanks.
Thank you. I'm curious, I'm trying to learn API, REST API, and you said that it's a good option to use. Do we need to have to make it to work on a server, or can we just do it with the desktop? Can we use API with the desktop?
Yes. So for both Python and R, you can connect to it from a desktop. The server is a kind of a heavyweight term. It's really easy to install, and it's not heavyweight in terms of computational resources. I normally run rserv and Python server on my laptop concurrently with no issues for the demos. But you don't have to install anything on your desktop other than Tableau. Tableau just needs to know where to send the requests about Python or R. We have a configuration screen. You just type in the address of the server and the port number, and it will send all the traffic over there.
I'm talking about Tableau APIs. Can we use them with desktop? Or
Sorry. General Tableau APIs. So depending on the API, yes. So if you're using something like the extract example I showed, there's an extract API. It doesn't require server or anything. But if you're using the REST API for the server to something like publish or update or get thumbnails for the stuff that's published, then you have to have a server. We don't have an API that is like Excel has VB script to modify the desktop, right? We don't have something like that at this point that allows you to work with the UI components in the desktop. Yeah.
Okay, thank you.
Would you let us know the integration between Tableau and big data like Hadoop or Hive and Storm?
If you want to connect to something like Hadoop, we have connectors, right? If you want to connect to Hive or Spark, we have built-in connectors. And if you want to run any code in them, since the data is big, you probably don't want to bring it into Tableau and run R or Python inside Tableau. You would rather want to do all the computation on the server. And all of these environments allow you to run Python or R on disk, on Hadoop, or whatever environment you want, or Spark. So you have to take advantage of database capabilities to run Python or R code as a pre-processing step before you bring the data in. Some of them will create artifacts, like Spark has data frames that you can create. And there are export mechanisms. So if you use Spark SQL context, there's an option to create Parquet tables. You can write them to a table, then you can query them from Tableau.
Thank you.
There's one other person over here that had a question.
Hi, for the Tableau extract command line utility, does that run on desktop, server, both, or anywhere?
So it doesn't currently run on Mac. That's one reason I did the demo on a PC, on my office machine. But it just needs Tableau EXE to run. I was running on a desktop, which kind of made sense, but you can run it anywhere you have a Tableau EXE for that specific one. It's not a separate API, it's just in the bin folder of the Tableau installation.
Okay, thanks.
Every example of the R or Python integration has shown the script being written directly in a calculated field. Is there functionality to link to a file that can be passed things? Because if we're going to have multiple files, say, dependent on the exact same script, it'd probably be easier for updating and stuff.
Yes, that's a great question. So in the TabPy session, we'll get into it. Both of our integrations have slightly different patterns for reusing code. In our case, there are two ways of doing it. One is you write your R script .r, right? You put it somewhere, and as part of the rserv configuration, you could say, load this script. As the rserv starts up, it will load all those scripts into memory. Then all the functions defined in those scripts will be available to you. You can just call the function by name instead of embedding the code. You could also do things like, let's say you trained a model, neural network, and you want to use it for scoring. You could say, I'll write it as an RDA on a disk, and I can load that RDA as part of my rserv config. Now I can call the predict function by calling that model by name that was trained before it is not part of my code. That gives you a lot of flexibility, so you can manage to control the code outside instead of trying to figure out all the Tableau workbooks that has this embedded script. For TabPy, we made it a more official thing because we have control over the code. We wrote our own. TabPy has a client API that allows you to manage the REST API, and it has a deploy function in the client API. So you can define a Python function and say deploy this function, and it will take that function and put it on the server, and it converts it into a RESTful microservice. So Tableau can call it. You just say TabPy query and pass the name of the service and the arguments. but it's a REST API. So if you want to put a different UI on top of it, use it in a different application, we just productionalized it for you.
Did I hear you right that for Python we can use any libraries we want?
Yes.
So like Anaconda or whatever, it doesn't matter?
So actually, we install Anaconda automatically. For if you go to GitHub and install, you will see, and we'll also download stuff like scikit-learn, NumPy, SciPy. So there's a bunch of things we'll download by default, but you can always add more, and you don't even have to restart the server. You can add more as it is running, and we'll pick them up automatically.
Good.
Can I use initial SQL with any databases?
Initial SQL with what?
Initial SQL option
Uh-huh.
with any database?
No. So let me go back to my slide. I have a list of all the databases we support, and some with parameters, some without parameters. If I get there. Last time I moved this fast, I made PowerPoint crash. Okay. Oh, initial SQL, okay. This is in the end, this is in the beginning. Oh, nope. Okay, here. So these are the databases that support initial SQL. Some of them support parameters, some of them don't. So not every database, just these.
Thank you.
Mm-hmm.
Hi. The Oracle store procedures, can you pass parameters to that? I thought you could only do it with SQL Server store procedures.
So Oracle, essentially you call stored procedures in Oracle through initial SQL.
Okay.
And
That's why
since it is with parameters, that's how it works.
So you would call an Oracle store procedure using initial SQL?
Yes.
Okay.
Yeah.
Thank you.
Looks like that's it. Well, thanks for your time.